Dear students, in thumbnail you have already seen this example I am going to cover in this video. Okay, so this example is of first order linear differential equation. So this is the second video of this playlist, and in the first video I have already covered what is first order linear differential equation, how to identify, what are its applications, and how to solve those examples, right? So see, in previous video, I simply told you the methodology, but here I am going to show with the help of this example how to solve first order linear differential equation. So let us take very short recap. Okay, let us take the overview how to solve the problem, and then we will start to solve this example. See, when you have differential equation in this format, dy by dx plus py is equal to q. Getting? Then we say the given differential equation is first order linear differential equation. Here p and q both are must be functions of x only. Okay, those should be the functions of x. That means y and any function of y are not allowed there. Getting? So you should have either constants or x. Then you can say it is a first order linear differential equation. Now the question is how to solve. First, we find the integrating factor having a formula e raised to integration p dx. We integrate this p with respect to x and we write it in a power of e. In that way, we will get an integrating factor, and directly we go for the solution, which is y e raised to integration p dx is equal to integration e raised to integration p dx q dx plus c. That's it. We simply solve this one and we get the solution. There is no need to worry about this left hand side, since integrating factor we already calculate here. The same thing you should write. But in case of right hand side, we supposed to solve that integration. Okay, so let us follow this method to find a solution of this problem. Okay, so let me check first the given differential equation in its standard format or not. Dy by dx, only dy by dx we want. We have dy by dx here. Y into some function of x. Yes, we have a y here and we have some function of x. So that is our p. In right hand side q means a function of x or constants. Constants are also allowed. No x is there, no need to worry, but see, constant 1 is there. So that will be our q. So let me clearly mention here p is equal to, p means multiple of y. What is multiple of y? 1 minus 2x upon x square, and q means right hand side, which is 1. Okay, so I wrote p and q. Let us move further. Now it's time to find integrating factor. So let us find integrating factor directly. Integrating factor, which is equal to e raised to integration p dx. So you may feel it is complicated since we are finding the integration in a power of e. If you are not comfortable with integration, you can solve it separately first. That means you can find integration p dx and then you can go for the integrating factor. You can put in a power of e. I will do it simultaneously. It's quite easy job. So this is equal to e raised to integration p. What is my p here? My p is 1 minus 2x upon x square dx. Okay, we are finding this integration in a power of e. See, it seems difficult, right? You cannot find its integration directly. So what will I do? I will divide separately. So tell me what will happen if I divide separately. So e raised to integration 1 by x square minus 2x by x square dx. So this is equal to e raised to integration. See, actually, I will try to cancel out some terms. You can easily see x will get cancelled. Here you cannot cancel anything, but I am going to shift this term to the numerator. X square is there. If you shift it here, x raised to minus 2, x cancel, 2 by x dx, right? So this is equal to e raised to. Now it's time to take integration, right? Two terms are there separated by minus sign, so we can take the separate integration. Now the question is how to find integration of x raised to minus 2. So there is some simple formula, x raised to n. Its integration is x raised to n plus 1 upon n plus 1. Whatever the power, you should add 1 there, getting 1. What will happen? Minus 2 plus 1, so it will be minus 1, and the same number in denominator. So that means you will have x raised to minus 1 upon minus 1 minus 2 is constant, we keep as it is. Okay, so let me tell you, 2 is constant. That means when you integrate 2 by x dx, so 2 is constant, it comes outside. So inside the integration we have simply 1 by x, and the integration of 1 by x is log x, 2 log x. Okay, so that will be the answer. So let me write directly 2 log x, that's it. So we solved this integration and finally we got this one. So this is equal to e raised to, but still it is looking complicated. Why it is looking complicated? Because power is negative, we have some negative numbers in denominator. So let us make it very simple. Minus 1, that means you can write minus here. X raised to minus 1. So when we have the negative power, we shift it to the denominator, then power will be positive. That means you will have 1 by x minus 2 log x. So that means in the power of e, we have this 2 terms. Now what will I do? I can take the separate power. So let me show you what I'm going to do. Let us do it here. Okay. So let me remove this part. It is not required. That's it. So it means e raised to minus 1 by x into e raised to minus 2 log x. That's it. I took the separate power. Okay. Since there is one rule, a raised to n plus m is equal to a raised to n into a raised to m. So this is the rules of indices. This is rule of indices. So I use that rule here. Actually, e, exponential function, and logarithmic function, these are inverse of each other. That means we can cancel out, but the problem is we have minus 2 there. So that's why we cannot cancel log and e directly. We need to remove that minus 2 from there. So now the question is how to remove minus 2. There is one property of log, that is n log a, which is log a raised to n. So if you have any multiple of log, you can write as a power. Okay, so what will happen here? E raised to minus 1 by x into e raised to minus 2 will be shifted there. So log x raised to minus 2. So there is no any barrier between x and log x. So e and log, exponential and log, will get cancelled to each other. And what will I have here? E raised to minus 1 by x into x raised to minus 2. So now the same technique I will follow. Okay, which technique? When you have negative power, we shift it to the denominator, then power will be positive. It means it is e raised to minus 1 by x into 1 by x square. That's it. Okay. So it is over. Finally, we got the integrating factor. Now we have to work for this solution. Okay. So let me write the solution. Solution is, what is the solution? Y e raised to integration p dx is equal to integration e raised to integration p dx q dx plus c. This is a solution. See, e raised to integration p dx is nothing but our integrating factor, and we have already calculated its value. So now our task is to simply put this value at its places. It means y, this one is e raised to minus 1 by x into 1 by x square. Inside, in the right hand side, inside the integration, again we have the same term. I will put its value here, e raised to minus 1 by x into 1 by x square. What is my q? Where is my q? Q is 1, so it's quite easy. 1 dx plus c, that's it. Okay, so most of task is done. Okay, so there is nothing to do in left hand side, simply we have to work on right hand side. Let me simply multiply 1 into y. So y e raised to minus 1 by x upon x square. Okay, integration. So 1 into 1 by x square, you will have same e raised to minus 1 by x and 1 by x square dx plus c. So now simply we have to find the value of this integration. But now the question is how to find the integration, how to find the value of integration. Since there are two functions and there is a multiplication. So generally when we have the multiplication inside the integration, we go for integration by parts, u into v formula, getting? But that formula will not work here, because in power of e we have one more complicated term, that is minus 1 by x. Okay, so it is better to substitute. Okay, so what I'm going to do, putting minus 1 by x is equal to t, I'm going to put here. Okay, so one more most important thing is, when you put anything, the next task is to find its derivative. That is a very important thing. So I'm putting this one, so I'm supposed to find its derivative. So you know the derivative of 1 by x. Okay, if you don't know, I will write here, derivative of 1 by x is minus 1 by x square. So this is a very important formula I'm going to use. Minus 1 is already there, and derivative of 1 by x is minus 1 by x square. Dx will be there. Derivative of t is 1, and I should write dt here. Okay, so minus minus plus, so 1 by x square dx is equal to dt. Minus 1 by x square dx. Okay, so that means this 1 by x square dx can be replaced by dt. Okay, so yeah, there is no more space to write, just make a screenshot of it, then we will move further. Okay, so let us write here, therefore y e raised to minus 1 by x upon x square is equal to integration e raised to minus 1 by x is t, so e raised to t, right? 1 by x square dx, that is nothing but dt, plus c. Now it looks very easy, right? What is integration of e raised to t? It's e raised to t, so it is e raised to t plus c. So see, t, they have not given this variable, we have taken for our convenience, so that's why it's our duty to replace the value of t. Okay, we need to resubstitute the value of t, which is minus 1 by x, so it is minus 1 by x plus c. So y e raised to minus 1 by x upon x square is equal to this one. This is a final answer. Actually, you can simplify it further. Okay, you can simplify it further. You can multiply both sides by e raised to 1 by x, so it will look better, but no problem. This one also you can consider as a final answer. So I hope all of you understood the how to solve such problems. Okay, so now what will I do? I'm going to give you one problem for homework. You have to try this problem on your own, and you can write to me your answer. Okay, or in next video I'm going to show you how to solve that problem. So by watching that video also, you can cross verify your answer. Okay, just make a screenshot of it, then I will give you the homework problem. So this is homework problem for you. You can try this problem. Okay, so we'll meet in next video. Thank you. See you.